Hello everyone, welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next dream offer. Wow, it sounds like a million years I've recorded a video. I actually did record two shorts. Anyway, so let's cut to the chase. So today we're going to talk about this problem, design a food rating system. So if you read it through, so essentially there are three APIs: food ratings, initialize the food system; change rating, so giving a food name, just assume, for the sake of interview or lead coding, assume everything is distinct, lowercase kind of thing. You can change the rating of a food. And there's another API, highest rated food. So given a cuisine, so each food has a name, a cuisine, and a rating. Return the highest rating of the food in that cuisine. If the ratings are the same, there's a tie, so return the items with the lexicographically smaller name. Relatively clear, explains the problem here, and then there's a few call patterns. I think the thought of this problem is when you first get this out, right? So initialization, obviously, generally the system, and assuming everything, again, this is in memory, it's mostly a data structure algorithm question, not a proper system design. So this will be initialized once, and then these two APIs will be called many times. I think 10 to the power 4 or something listed here. It depends on what you want to optimize, right? So generally speaking, people want to optimize this highest rated because this is assuming you're building a Yelp app or something like that, Google reviews. This we want to be like fast in terms of performance, O1. And this hopefully it will be O1, but depends on how much space you want to trade off. The implementation I did was a ON, worst case, will still work. So here's my initial thought. So generally, we will maintain two maps. And I guess first point is every time you're asking about, hey, the highest, the lowest rating for algorithm questions, a priority queue or minimal or maximal heap will come into place. So this is definitely sounds like a maximal heap to me. And given the structure of this problem, a food has three attributes, right? Name, cuisine, and also the rating. It makes more sense to put them into a class, and then you can implement the comparable interface so that you can maintain the orders. But especially when there's a tie, you want to return the lexicographically smaller ones. And then we'll leverage two maps. What I used is a food index map and also cuisine index map. A food index map essentially is given a food, you want to return the food object. So this is at least guarantees O1 access. And then this is when the highest rating API, given a cuisine, you want to just pick the top of the maximal heap, return the value. We'll talk about the follow-up later. So now we quickly look at the implementation. Again, for the sake of interview, you can use the whatever your IDE to generate those code, boilerplate getter setters, but I will just talk to the interviewer, make everything public, but explain to them. I do know, those kind of things, getter setters, just basically for the immutable kind of design patterns. Initialize the constructor. Here is where we implement the comparable interface, compare to, right? So if the rating is the same, just return they have the same rating, just return the smaller sorted lexicographical order, or just based on the ratings return. There's an indentation problem. Keep two maps, as I said. This is initialization. So I used to just write code like this, but I think if you use put if absent, that will make the code look a little bit cleaner. Just keep in mind that you can't just directly add here because it will return null if this not exists. So you still have to write it like this, but it saves like two lines. And for change rating, the gotcha is because essentially the food is just an object in Java, right? So it won't automatically, if you update, you can try it yourself. If you update the rating of this object in the maximal heap, which is priority queue, it won't automatically change the order because there's no, this object is not like a listener or anything. It's not like they have an on event kind of thing. So it will stay the same. The order won't be the same. So what you have to do is you have to remove the object, and then you have to add object again so that the new rating will be properly reflected into this priority queue. So that's pretty much, this is the part we make the change rating instead of log n by just removing one or just update one, I guess, which is on if you don't do any kind of insertion or deletion, which is o log n. This is the part of make it like an on worst case, because in order to remove an object from a priority queue, it requires a full queue scan for the Java implementation. So this is why. And the highest rating is easy, right? Because it's the maximum heap, you just get the food, O1, and then pick it out, which is also O1. Here I explain the time complexity, and the space complexity is ON to the worst case that it grows as part of the food names skills. References. Okay, back to the follow-up question. I think the more interesting thing, I also put a link here on how YouTube calculates the views. It's a very similar thing, right? Like how Yelp calculates the views. Obviously, YouTube video views or likes has a higher skill than Yelp. Think about how you actually put this into a system design question. How you want to design this? What's the trade-offs? Obviously, you can maintain a hash map, just a single-threaded machine, right? How do you actually do it? Are you going to use some queue, message passing, estimation, distributed counting, that kind of thing? Anyways, that's about it for this this problem. If you have any questions or what kind of videos you want me to make, feel free to leave any comments. I'll see you guys next time. Bye.